If the critical angle for the total internal reflection of vacuum. So how do we solve this? We know, right? Sine theta equals to 1 upon mu, right? 1 upon mu. And then where this is critical angle, right? And this is a refractive index. What is this? Refractive index, right? This is a refractive index. Now what is refractive index? It is actually mu is defined as the speed of light in vacuum upon the speed of light in the medium. Okay, so the mu is defined as the speed of light in that medium is compared to the speed of light in vacuum. So solving, we get sine, the critical angle is given at 30 degree and the mu is given by, now the mu is given as c by v, right? C by v. So sine 30 is 1 by 2. And why it is coming? How to turn off this? How do I turn off this? How do I turn off this? I don't know, but it is keep coming, you know. Just let it be. And it becomes c by v becomes v by c, right? Reciprocal. And then it's actually c is what is speed of light, and it is 10 to the power. And solving, we get v equals to 1.5 into 10 to the power 8 meter per second. This is the answer. So this becomes your answer. When light travels from air to glass, which of the following properties does not change? So its frequency doesn't change. Why? Frequency of light. Frequency is the property of sound. So frequency is the source. Okay, it is a property of source. Property of source, right? It is a property of source, not the property of medium. Okay, so frequency is the property of source, so not the property of medium. A person is a spectacle of power plus he is suffering from definitely long-sightedness. Why? In long-sightedness, what becomes is our eyeball elongates, right? So no, eyeball shortens. So long-sighted means eyeball shortens, right? Due to this eyeball shortness, the image is formed behind retina, right? Image is formed behind retina. And due to correct this defect, we use what we use convex lens. We use convex lens. Lens is to be used. So since we use convex lens, the power of convex lens is always positive. So since it's given positive, definitely it is suffering from blindness. For short-sightedness is always opposite to this thing, you know, it's always opposite to this thing. Okay, a galvanometer can be changed into ammeter by connecting low resistance in parallel. So if I denote galvanometer as G and if I current flow, if I just put a one resistor in parallel to the galvanometer, then what is become this system, this whole system, you know, this whole system becomes now ammeter. But note that this resistance should be of low, very low resistance, because if this is become high, this doesn't act as galvanometer because all the current flows through lower resistance, right? So this must be low. But what about voltmeter? In voltmeter, if we just connect where is the razor? If we just connect a resistor in series with the galvanometer, with just resistor, and this whole system is now termed as voltmeter. What is galvanometer? Galvanometer is the one device, right? Or this is just a resistance, or we can say galvanometer is just a resistance, a device which measures small current. Okay, so it measures small current. It measures small current. Okay, it measures small current, the magnitude of milliampere. It just measures small current of milliamperes. The total internal resistance of 2.1 volt cell, which is the current of 2 ampere through a resistance. We are actually asking if this is a cell, okay, This is internal resistance. I'm denoting internal resistance small r, and this is a cell of having volt, and this is a whole cell, okay, and this is connected through external resistance. And now we are asked to find, what do you find? The external resistance, right? So this is what, so this is about to find, and the current is flowing from higher potential to lower potential, plus to minus, and the current's value is given as 0.2 ampere, okay, and the voltmeter V is given as, how much volt is given? It is 2.1 volt, and this small r is given as 10 ohm. So just nothing is there. There are two. This is just a series connection where two resistors are in series. The two resistors, these two resistors are in series. So we just add it. We just apply Ohm's formula. And what is Ohm's law states? Ohm's law V equals to IR. So what is the R? R is not R is the equivalent of both resistance, right? So R is just the resistance this ohm plus this resistance. So actual R becomes, what is small r, internal resistance, for actual the external resistance. So we can just write it I into capital R plus small r. So I'm denoting capital R is external resistance and small r internal resistance, okay. So now what is I is given 1.2. The volt is also given 2.1 volt. And what is external resistance? External resistance we are about to find, and internal resistance is given as 10. And you solve for R. We have to solve for R. Now you have to solve for R, solve for R, solve for R, and we get the value 0.5 ohm. So this is now specific resistance of a resistor. So what is specific resistance? It is denoted by delta, right? So delta equals to rho L by A. But it neither depends upon this thing, neither it depends upon length, nor it depends upon area. So what is it? It actually depends upon properties, property of material, property of material. But resistance depends upon, but if I just talk about resistance, okay, so but if I just talk about resistance, then it depends upon length and area. It depends upon both the length, it depends upon both the length and plus area. But the resistivity doesn't depend upon length and area. It is the property of material, it's the property of wire. So it's the property of wire. So it's done. Now let's get to another one. What does it says? It asked the angle between the particle velocity and the wave velocity. What is in transverse wave? This is what is transverse wave, right? So in transverse wave, if this is a direction of propagation, if this is direction propagation, and this is a direction where the particle do SHM, simple harmonic motion, in this direction, which is perpendicular to the direction of, so it is a particle, it's a direction of oscillation, okay. So what is this? This is a direction of oscillation. So the direction of oscillation is always perpendicular to the direction of propagation. So the particle vibrates in this direction, vibrates in this direction, but the actual wave propagate in this direction. So this is always perpendicular, so it is pi by 2, which is 90 degree. Okay, light year is the unit of distance, for measuring the cosmos distance, the distance from one planet to another planet, or the distance from one solar system to another solar system, or the distance from one universe to another universe. We use the term light years, okay. So 1 light years equals how much? 3.14 into something 10 to the power, I forget the actual, so no, it's actually 9.8 into 10 to the power, what was the power? I don't know, it's 14 or something, kilometers, okay, or meters. So this is what is 1 light year. So I just consider value, okay. So I just forgot the value, okay. So the question, the homework is, how much is 1 light year? The homework is, how much is 1 light year? So this is your homework, okay. Just do it right now. And the momentum of the particle is numerically equal to its kinetic energy. So okay, so this is very easy one. We just you have to modify the formula, that's it. So what is kinetic energy is given as? So I'm denoting kinetic energy as Ke, and K, we know K is equal to half mv square, where m is mass and v is velocity. So we can just establish a relation between momentum and kinetic energy to find the velocity. Remember, v should be in the equation. So what we can do is, we can do kinetic energy equals to half m v into v, because v square, there are two v's, right? So I can just denote this. This is just the momentum, right? So this is just being the momentum. So kinetic energy equals to half, momentum is denoted as p, where p equals to mv, right? Everybody knows this. So v is also there. Now what do we find? We have to find v, and the question is already saying that momentum of the particle is numerically equal to its kinetic energy. So this term and this term get cancelled. So cancelling this term, what we get now? So we get our final velocity, and that is, what do we get? Final velocity, and that is 2 meter per second. Okay, so 2 meter per second, but this is not to be remembered. Okay, don't by heard it, don't by heard it. The only formula that you need to by heart is the momentum kinetic energy relation that I already mentioned in the previous video. What is that? Kinetic energy equals to p square by 2m. So this is what is you have to remember, not this one. This one is just you have to modify this formula. You have to think accordingly and do this. Okay, so this one very good question. This one is very good question, and this is what you have to remember. If you just forget it, you can just derive it on the spot. It's very easy. You just multiply by or divide by mass on both sides. Sorry, multiply and divide by mass on both sides. So dividing and multiplying on both sides, we get, so this becomes mass into mass, momentum square upon m. So this is very easy. Okay, so now if the planet consists of satellites whose mass and acceleration both are half of the planet acceleration due to gravity. This is also already discussed many times. Okay, so we know g equals to small g, which is acceleration due to gravity, equals capital G, which is universal gravitational constant, mass of the planet or whatever the body is, into upon r square. So this is what is, right? So what is this? Question says the mass and radius are both half. So what happens to the new acceleration due to gravity when denoting as g dash, when we half the mass and radius? What does it become? So when you just half the radius and mass, both becomes, so m by 2, and also we have the radius. So what do we get? We get 2 to the 4 upon 2. So we get g, we get 2 times, right? So 2 times, we get 2 times gm upon r square. So this g, so this is what is g, so this is g, right? So this is g. So we can just substitute as, what we can substitute? We can just substitute 2 into g. So it becomes, and what is g of our earth? So it says it is that of it is compared to the earth. So the planet's gravity acceleration due to gravity, we can conclude that the planet's acceleration due to gravity is 2 times that of acceleration due to gravity on earth. So we said in our this is 9.8. So solving this, we get 8 to the 8 1 8 to 16 1 9 to 8 19. So we get 19 meter per second. So this is what it is. So 19 meter per second. So I think it's done, right? So okay, so hopefully hope you get the point, and just best of luck, good luck. Okay, so bye, I'm ending the video. So thank you. I'll just write it with pen. Green pen. So thank you.